Since the concept build for the used oil burner worked, a simple design with a consistent flame to burn the oil effectively for a duration of time was accomplished, I decided to finish out the build with what I had in mind. Get a nice looking oil container and oil feed system going to the burner. As I thought before, the exhaust side of the burner needed more air before it went straight into the exhausting tube, so I ended up picking up an 8-inch exhaust tip with another reducer to fit with a 2.5-inch straight pipe that originally came with the kit. Mounting it in a fashion that would be able to swing it out of the way seemed beneficial so as to be able to ignite the burner from the exhaust side if I have to. This is all a trial, so I wasn't for sure how the outcome would be. And since the burner did work so well last time, I wasn't going to start it again until I at least had a cement backer board behind it all to help protect the wall. I've tested the burner 2 times since putting it together to make sure starting it wasn't a fluke. After taking down the original design, I got to work putting up the cement backer board, so I got 4 fender washers to finish holding it all in place. I decided to draw 2 lines down the board where the wall studs were for alignment. After getting the board remounted to the wall, I went ahead and turned the brackets in a manner that looked better from the front. More finished. So now it's time to start adding pieces to the build to make it look a little more complete. And if all these materials work, then it will be ready to exhaust outside. Once secured, I had purchased a new wick material to try out in the burner. This is a ceramic wool style material. It feels like dense cotton candy and pulls apart the same, like a denser fiberglass insulation. It's supposed to withstand up to 2700 degrees Fahrenheit as opposed to the 1700 degrees Fahrenheit carbon felt I used last time. I'll give a spoiler alert that that's not necessarily true in this usage. If you stay tuned to the max capacity video where I put it to the max test, the ceramic ends up shooting out of the exhaust side in a fireball. I cut a 1 1/4 inch wide strip and ended up using a length of 7 inches or so. I stuffed it down into the bottom of the burner bend and pulled it through a bit to the other side so it was even. I picked up a universal stainless steel radiator overflow tank to fit the style of the veg oil burner concept build. It came nicely packaged in a bubble wrap, standing at 10 inches tall by 3 inches wide, with 2 ports at the bottom. The one in the middle is the drain port. That's the one most concerned with. The top has a 1.5 inch to 2 inch screw cap with a tight rubber seal. It came with the necessary hardware to mount it. I ended up picking up more oil draining hardware than I needed to figure out what options I had available, but the necessity was the 1/4 inch inner diameter by 3/8 inch outer diameter clear hose. I picked up a pack of 1/4 inch 3-way barb fittings and a 1/4 inch shutoff valve for the oil supply. If there was a chance I would have 2 oil tanks, a 2-way shutoff valve would work great. Putting the final pieces back on the oil burner, including the riser and the fan, it was time to start mounting the oil can to the wall with the included hardware in the kit. It went on solid. Just using a simple eye for measuring, I started cutting the clear 1/4 inch hose to proper lengths to accept the next piece in the oil feed system. I attached the top pieces with a hose clamp, but didn't have to worry with the 3-way fitting as it fit very snug. But for good measures, I did use hose clamps on the rest of the metal fittings and copper oil feed tubing running into the burner. Moving along with the exhaust build out, I purchased a 4 inch by 2.5 inch reducer. I tightened it down into the back of the 8 inch exhaust tip I picked up on Amazon as well. Sliding the original long pipe into the reducer, I then tightened the clamp in a manner that would allow the shallow end of the exhaust tip to swing over the top of the burner flame and out of the way when I would need to clean or ignite the burner. Once the hangers were in place, the next step was to mount it to the wall. So putting up another support and marking out the holes to mount the 4 total mending straps to hold the angle of the hangers and getting it all tightened down at just the right height was important, and getting the hangers to act as a straight hinge to allow the exhaust side to swing out of the way. All tightened down, it worked well actually. The addition of the oil container and exhaust tip really complement the simplicity of the build. With a no-weld approach to have an oil burner that the average shop DIYer could put together in a couple hours, making the style and simplicity of the build a success. As a no-weld simplistic approach goes, this build hit the nail. Using a stainless 10-inch by 3-inch radiator overflow tank as the oil can to feed down a 1/4-inch clear tube, governing the flow of oil with a 1/4-inch brass barb fitting to the copper tube that delivers oil all the way down to the burner, a 12-volt adjustable speed blower fan to deliver fresh air to the flame, all flowing down the riser to the oil catch bin onto a ceramic wool wick for ignition, exhausting it all out the 8-inch exhaust tip, and eventually porting it to its final destination of outside. But first, let's test the build to see if the whole thing works. I went to the store and got some regular vegetable oil and poured about half a quart into the oil container, capping it off and testing the oil feed to make sure the flow of oil works correctly. I moved on to try and get this thing lit. I used a piece of ceramic felt and doused it with some denatured alcohol, hoping that it would stay lit long enough to get the oil soaked up and going. Moving the exhaust tip out of the way to see, I dropped the flaming ceramic into the burner for trial 1. Putting the fan back on, I started adding oil. It's getting there. But soon realized I put the flame out with the oil. So I then decided to just pour the rest of the alcohol down into the burner and get it lit that way. This is where the second oil tank with a mixture of alcohol or kerosene with oil would benefit. That way it could be started with a better starter than just alcohol or paper. So it's time to see how long it takes to get going. There would still sound like there was a flame inside. And it kept up. But I bet the ceramic felt has soaked up the majority of the oil. So I added more to see what would happen. I heard the oil hitting the flame, checked it out. It's going full on. The flame started to go out, so I opened it back up and hit it with the MAPP gas again. This time it worked. I started the air slowly to the flame, as it was still pretty weak. But slowly getting hotter and larger. A little more oil. And a little more air. There's one more thing I might try before exhausting this out the wall, and that's getting a 2.5-inch diameter perforated stainless steel tube that comes out of the top of the exhaust tip. This would keep the flame hotter for longer while allowing more impurities to be burned away with the extra air to the flame. When it comes to exhausting this outside, I will try and find a straight pipe with a Y or fork introduction. Being upside down, I can hook up the exhaust fan to the lower fork side and blow the air out, vacuum style, to the burner. That way, I can keep the fan out of direct alignment of the hot exhaust. I'll have to thank Clyde D. Meisters on YouTube for the mention of the fan and air ports in the exhaust tube. Thinking along the same lines, that was a great suggestion. I'm hoping to accomplish this with a perforated tube. Along with Douglas Poe for placing the exhaust into the barrel. Although I did want to stray away from cutting and welding, exhausting into a 16-gallon steel drum would be a perfect option as to keep the flame hot and contained for exhausting. To be quite honest, it smells like driving by a Burger King with their flame-cooked burger smell coming out of the building. The flame continued to grow hotter as the U-bend was heating up. About 4 minutes into the flame, it made a small popping sound. I've come to realize this is the sound of the burner getting hot enough to make a more complete ignition of the oil. After that, the flame was more consistent and showed signs of staying lit without monitoring so much. I let it keep going for a bit and swung the flame cover over the top for hotter exhausting. Finalizing the oil burner concept build. Hit the like and subscribe button to stay tuned.